This is section 4.10, part 3, where we're going to write a quadratic function in standard form. So a reminder, standard form is y equals ax squared plus bx plus c. So we can see our first problem, and it looks like we're given 3 points. We're given the point of -2, 0, 1, 0, and 2, -4. What we want to do here is our goal is to get a system of 3 linear equations. We're going to have to work with 3 equations, and we're going to have to solve that system. And we've learned how to do that already, so that once we get our system, hopefully it'll be a piece of cake. But how do we get our system? Well, in order to do that, we're going to take each point individually, and we're going to substitute it into this equation and just get an equation from each point. So this equation will yield this point will yield one equation, this point will yield a second equation, and this point will yield a third equation. Thus we'll have our system of 3 linear equations. So let's do that first. Alright, so I want to see my points. Okay, so we'll start with our first point of -2, 0. We're going to plug in to the equation y equals ax squared plus bx plus c. So my y value is 0. The x value is -2. And now we'll simplify. -2 squared is +4. 4 times a is 4a. -2 times b is -2b plus c. This is the first of our 3 linear equations. Next, we're going to do the same thing with our second point of 1, 0. We're going to plug that into y equals ax squared plus bx plus c. So my y value is 0. My x value is 1. 1 squared is 1. 1 times a is simply a. 1 times b is b. And then c. So we've got our second of our 3 linear equations here. So we've got 0 equals a plus b plus c. And then we're going to use our third point. Do the same thing one last time. 2, -4. We'll plug that into y equals ax squared plus bx plus c, where -4 is my y value, 2 is my x value. So I have -4 equals 2 squared is 4. 4 times a is 4a. 2 times b is +2b plus c. So here's my third set of linear equations. So once I do that, I'm going to write this system out, and I'm going to basically switch it. Instead of having 0 equals, I'm going to write it the way we're used to seeing a system. And I'm going to put 4a minus 2b plus c, and I'm going to put the equal sign on the right-hand side for all 3 of them. So just basically swap locations. Here I've got a plus b plus c equals 0. And then lastly, I've got 4a plus 2b plus c equals -4. So here is our system of 3 linear equations. And we learned how to solve this using matrices. So that's what we're going to do. We're going to take this system, and we see we have 3 equations, a, b, and c, 3 variables. So it looks like we're going to need a 3 by 3 matrix. And I'm going to just take the coefficients. So in the first line is going to represent the first equation. So the first coefficient is 4. Second coefficient is -2. Third coefficient is 1. Second equation will represent the second line. So the first coefficient is 1. Second coefficient is 1. And the third coefficient is 1. Third equation represents the third line, or the third row. So I've got 4, 2, and 1. Next, I have a 3 by 1. These are where my variables go in the order that they're given to me, and that's A, B, C. And then I have another 3 by 1, which are the solutions on the right-hand side, which is 0, 0, negative 4. And what we're going to do, we're going to go to our calculator, and we're going to plug this into matrix A. We're going to plug this into matrix B, and we're going to get our solution of A, B, C by taking the inverse of A and multiplying it by B. That's going to be our goal. So let's take out our calculators and work with our matrices. So I'll clear this, clear this. So we're going to see if I could slide this over a little bit. It's being a little fussy today. So, all right, let's get into our matrix screen. So remember that second, then this x to the negative first power. So second x to the negative first power. I'm going to go over to edit. I'm going to edit matrix A. Remember, this is a 3 by 3. And I'm going to populate all the rows. So the first row is 4, negative 2, 1. The next row is 1, 1, 1. And the last row is 4, 2, 1. So 4, negative 2, 1, 1, 1, 1, 4, 2, 1. Remember, always check to make sure you input your data correctly. All right, otherwise you will end up getting an incorrect answer, which is not good for anybody. All right, so I'm going to come back, and now I'm going to edit matrix B. So I'm going to go over to the edit screen, go down to matrix B, hit enter, and we have a 3 by 1 matrix here. And the values are 0, 0, and negative 4. So 0, 0, negative 4, that looks good. All right, so remember my final answer, I'm going to move the calculator over real quick, is going to be the inverse of A times B. So I'm going to go back in, and now under the name screen, I'm going to choose matrix A. Then I'm going to come down to this x to the negative first button. I'm going to punch that, and that's going to make this the inverse of A. And I'm going to multiply that by matrix B. So go back in, under the name screen, go down and choose matrix B. So I have the inverse of A times B. Hit enter, and there's your solution. Negative 1, negative 1, 2. So let's slide this back over here. And the calculator is going to disappear real quick, but we're going to remember that the solution is negative 1, negative 1, 2. So my final answer is A, B, C, negative 1, negative 1, 2. And I know I just said that's your final answer, but that's really not your final answer, because what you want to do is write a quadratic equation in standard form, where standard form was y equals ax squared plus bx plus c. Well, guess what? Now we know a is negative 1, we know b is negative 1, we know c is 2. So I can say y equals, what's the value of a? Oh, that's negative 1x squared, plus the value of b is negative 1x, plus the value of c, which is 2. You could leave your answer like that, but a more common answer is simply writing negative x squared minus x plus 2. So I'm going to leave this as my final answer. If you had left this as your final answer, though, you would get full credit there. So that is part 3.